Starts Chapter 5 and Gregory Mankiw, and now we're going into the microeconomics section of the course, and the title of this chapter is Elasticity and its Application. Elasticity is a big concept in microeconomics, specifically has to do with the demand side of things. So let's get started. Elasticity is a measure of how buyers and sellers respond to changes in market conditions, i.e. prices. So what does the word respond mean? It's a big term in this chapter. It means, given a change in price, how will your buying habits change? So if I'm currently buying a six-pack of Coca-Cola for let's say $3. Well, that does seem kind of high. I mean, let's say $2. If the price rises to $3, will I still buy that six-pack of Coca-Cola? Well, a lot of it depends upon your measure, your willingness to respond to those changes. And in other words, it depends on the type of good that you're buying. Now, elasticity allows us to analyze supply and demand with greater precision. We can have a numerical measure of how you will respond to changes in prices. Now, we're going to focus primarily on the buyer end, but there is certainly these types of impacts on the seller end as well. Now, something to consider, something to think about. Maybe you can write down on your own right now. Name 3 necessities and 3 luxuries that you would buy. Okay, I'll let you think about that and let you write that down. A necessity would be a need. A luxury would be a want. So I might think a necessity would be toilet paper. I think a luxury might be a jet ski. So, and then once you've written down those necessities and luxuries, why would you think so? Why would you think one is a necessity and one is a luxury? And if you write this down and maybe compare it with people that you know, friends and neighbors, or family members, it may be that what you consider a necessity is different from what another person may consider a necessity, and likewise a want. Now, elasticity gives a numerical measure of whether an item is a need or a want. And we're going to define a need as if the price goes up, you're still going to buy it. A want is if the price goes up, you're going to think twice about buying it. Let's go on to the next slide. Price elasticity of demand. Now, here's the definition in words. The price elasticity of demand is a percentage change in quantity demanded given a percent change in the price. So that in words is going to be what was stated in the previous slide, much more precise definition. So given what's going to happen in price, how are we as consumers going to respond in terms of our purchase of the product, our quantity demand? It is a measure of how much the quantity demanded of a good responds to the change in the price. Are you still going to buy? Are you not going to buy? How much more are you going to buy given the change in price? All right, our next slide is going to be, shall we say, the mathematical interpretation of this line. And price elasticity of demand is computed as the percent change in the quantity divided by the percent change in the price. And in symbols, you can see right there. You can see the percentage sign right there. And this little sign is the called delta. And delta, you can see it right there with my cursor arrow. Delta is a Greek symbol that means change. Now, when we look at change in these principles courses, we're going to mean the difference. So the change between a price of 1 and a price of 2 is going to be the difference. 2 minus 1 is going to be 1. That's going to be the change. And we can see here the percent right there for price and the change in price. So the price is going to be always on the bottom. I always get a little confused on that as well. But just think of it this way. The independent variable is going to be on the bottom. The dependent variable is going to be on the top. All right, let's explore this a little further. And let's chat a little bit about elasticity, percent change, and slope. Now, because the price elasticity of demand measures how much quantity demand responds to the price, it's closely related to the slope. So one could look at the unit change. And if you remember, the slope is always the rise over the run. Excuse me, it sounded like Elmer Fudd there. But instead of looking at unit change, elasticity looks at percentage change. Why do we use percentage change? Well, the answer is that percentage change gives us a better sense of the change in relation to the event. Was the change a big change or a little change? I'll give you an example. Let's say that your income decreased by $10,000. Now that may seem like a big change, but if your income was $1 million, then your income loss was only 1%. Now, if your income was $50,000, that would be a big change because that would be a 10% change. So that number, that percentage, gives you not only a sense of the numeric value, but also in relation to what preceded it. Also, percent change allows you to talk about what happened to you behaviorally without actually revealing the numbers. And with income, that's kind of important. You may not want to reveal how much money you lost or how much money you actually have. So you might say my income decreased by 10%. And that tells the listener, wow, that was quite a bit. Because you would know in your mind what a 10% change would be. But the person who told you 10% didn't reveal either the amount of the loss or how much they were making. Only the rude person, which I can sometimes be, might ask further, what was the loss and what was your starting gain? So people use percentages all the time to give a sense of the change without revealing the actual amounts. Happens all the time. So elasticity, well, we're going to very much focus on percent changes. Okay, let's do a little assessment on percentages here. And you can go ahead and try to figure this out. I'll give you a little bit of time before I reveal the answer. If there are 50 tomatoes in a store and you picked 16 of them, what percentage of the total did you pick? Give you a little bit of time there. And if you said 32%, you were correct. And the way to get that is to say, let's see if I get my pointer here. There we go. It would be 16 divided by 50. Boy, I need some work on this. Times 100 is 32 per cent. Okay, you have to divide by 100 to move the decimal point over from 0.32 to 32%. Alrighty. next one. Paul, that would be me, used to weigh 200 pounds last year. I'd like not to think so, but we'll just use this for um, expository purposes. But now he weighs only 175 pounds. How many pounds did he lose, and what was the percent change of the loss? All right, let you think about that for a little bit. And if you guessed 25 pounds, you are correct. Now the percent change with the loss is a little trickier. Percent change of the loss is always the change. Wow. Well, I need to work on this. Change over the base. Wow, that is sloppy, but you get the basic idea. Now the change in this case was the difference between 175 and 200, which is 25. The base is the tricky part. The base is where you start from, and when you start from is 200 in this case. So 25 over 200 is going to be 12.5%. Now, if it was a weight gain, you weighed 175 and you now weigh 200, the change is still going to be 25, but the base is now going to be 175, and you're going to get a very different answer. Okay, number 3, what is the average between 300 and 330? So think about that for a second. And hopefully you guessed 315. And you can figure that out by adding 300 and 330, which gives you 630. Divide that by 2 because you have two numbers there, and you get 315. The midpoint is the number that's right in between. That is also going to be 315. The midpoint, or the median, is where half of the numbers are greater and half of the numbers are less than the midpoint number. Okay, very good, and keep this in mind as I talk about percentages in the next section of the slideshow.